Okay, so we are getting to the 2-minute mark. It's time to get things rolling. Good afternoon, everyone, and it's great having you here as we continue this month's series aptly titled Future Forward with AI. And I want to start the show by welcoming our very own guest of honor, Michael L. Michael is a director of the Improving Calgary enterprise with over 20 years of experience as an architect, team lead, and mentor. Currently focusing on generative AI solutions, Michael has also designed and built software solutions spanning scalable cloud-based systems to web and mobile applications for companies ranging from startups to large enterprises. Beyond his tech endeavors, Michael is an enthusiast of traveling, golfing, snowboarding, and mountain bike. I am very thrilled to introduce him today with his talk, Building Reasoning Applications with Generative AI and Agents. But before we start, I encourage you to use our Q&A feature so you can ask questions, which I will send him his way at the end of the presentation. In the rapidly evolving landscape of artificial intelligence, reasoning applications are emerging as powerful tools that mimic human thought processes to tackle complex problems. These applications utilize generative AI and intelligent agents which can analyze data, make decisions, and generate insights in innovative ways. And to talk about this and much, much more, I want to welcome my good friend Michael L. from Canada. The microphone is yours.
Thanks for that intro, Armando, and thank you everyone for joining. I hope the summer's treating you well. As I was mentioning to some folks backstage here in Calgary, there is some snow in the mountains, so enjoy it while we can, right? But yeah, today we're going to talk about building reasoning applications and agents. And hopefully, and that circles around generative AI for sure. There's many aspects to when we talk about AI. This is on the generative side. And, hopefully at the end of this, we kind of have an understanding what reasoning applications are and what agents are. Now, before we begin, let's kind of take stock or let's take a collective breath, right? There has been, I'd say, ever since ChatGPT was released, there has been an onslaught of, thought around AI and Gen AI, hype, expectations getting pretty big, right? We're probably from a Gartner hype cycle, maybe at the peak of our inflated expectations, might even be on the downward side. And, and this is a good thing, right? Because now, and it's expected. And now we're kind of saying, okay, hey, how can we realistically use this stuff and within our organizations to actually add value? And, that's kind of an important part as we kind of take stock and we see where we are. We're like, it kind of feels like it's going to be more of an evolution than a complete revolution, right? Where everything just switches over. And we still want to be trying everything with generative AI and these large language models. And, right now we're in a bit of an ideation phase to see what works and what doesn't work, right? Where does it shine? What are its strengths and what are its weaknesses? And yeah, we just kind of want to move forward and, keep that in the back of your mind as you're kind of playing with this stuff is we don't want to just kind of, it's probably not in our best interest to stop identifying areas and understanding how this works and how we can weave it into our systems. And that's kind of, the crux of this kind of a topic and conversation. And we're going to go over one kind of way to do this with these reasoning applications of the agents. Okay. So let's just kind of look at the overview of how this kind of presentation is going to be is, we're going to start with some concepts, right? We'll go over some diagrams, discuss some main attributes of reasoning applications and agents. And then what we're going to do is we're going to see it in action with, a product or service that we've developed called the Data Explorer. There's only so many pictures and I may not explain something very well, and maybe if we see it in action, it might connect some dots, right? So we're going to be jumping back and forth between concepts and a live demo. And I always enjoy doing these demos with a non-deterministic generative AI, right? Because it brings an air of excitement, to say the least, but typically pretty good. And, then we'll kind of dive into some patterns and strategies throughout, but we'll kind of bounce between these things. Hopefully it's not too jarring, right? Because we jump around from slide to demo, but hopefully, yeah, we'll kind of walk ourselves through that, and I hope these points are hammered home by the end of this presentation. Okay, so as I kind of mentioned, you know, when we see this like little digital brain or digital cloud, uh, think of this as these large language models, right? These are the models that are built by OpenAI, Anthropic, Google, Meta, right? There's a lot of these coming out, right? They're trained on billions of parameters. They know lots of stuff. Um, Pretty impressive when you interact with them, right? The ones behind, the chat GPTs of the world. And really what we're focusing on is building how do we integrate that within our software or how do we build software around it, right? Um, Probably going to be a pretty big thing as we move forward during this evolution, but that's really what we're going to talk about here. And, the fact that these models are trained on billions of parameters, they actually don't know, let's say your organizational data, which is a good thing. And so like, how can we take advantage of the power within these models and, maybe weave in our own information? Okay, so the first architectural pattern is retrieval augmented generation. Now, we're not really going to talk about this. That's been, the past year, very popular architecture and design pattern, right? A lot of products popping up, a lot of ways to kind of use this to weave our data into, this model so we can start to interact with it. But super high level is we're going to have our own information and our own data. We're going to like rip it through a pipeline, chunk it up, store it in like that's something called a vector database in such a fashion that, let's say we're in a chat application or an interface, the user asks a question and we're going to say, hey, provide me some context or some documents that's relevant to my question, and we're going to weave it into that question. We're going to change the kind of how we pass that in with this extra context that these models don't know about, right? So they have the ability to answer that question. And so super high level, that's RAG architecture. But you see, generally, this is kind of a acyclical, forward-moving kind of process, right? Now we're kind of going to get into, let's say, reasoning applications and agents. And, first thing you'll notice, right, is we got a little bit of a circular pattern here, right? And throughout this presentation, I'm going to represent these agents as a sprocket, right? And the combination of the model and your agent will kind of view as a reasoning application. So, the difference here, and like when we talk about software design patterns and principles, they all kind of still are relevant, significantly relevant, as we start to build these kinds of systems. So, for example, if we build an agent, right, we want to focus that agent to be, good at one thing, right? So single responsibility principle still valid here. We don't want it to be too big and handle too many things. We want it to be good for one thing and one thing only. And what we're going to do is when we identify what we think this thing is going to do, this agent, we're going to arm it with some tools, right? And that's kind of the wrench in the screwdrivers here. And, we're going to have descriptions on these tools. And, just at super high level, let's think of these as functions, right? Integrations with our internal systems to maybe, going back to that augmentation, provide some information or do some calculations or do something specific to our organization so that, we can provide some extra information into the model to solve our problem. Okay? So this kind of interaction between our agents and our tools, this all happens like, within our process in let's say our cloud environment. But that's the execution of all this stuff is behind, is inside our organization, not happening, in the model side. So so really what's going to happen here is we kind of let's say we're in the same situation where we have a chat interface, right? A question comes in and our agent is actually going to pass that to our large language model, our model. And, we're going to provide it some extra information as well, saying, hey, we're going to set the context of what this agent does. I'm really good at if we've played with ChatGPT, you say, well, you are like an expert in something. We're going to kind of set the stage for it in what's known as a system prompt. And we're going to provide some information about the tools available to this model in order to answer this question, right? Because it's not going to knows about a lot of stuff, but doesn't know about our information. So, so what the model's then going to do, and this is why we're going to call these like reasoning applications, is because it's going to say, okay, I got this question. I kind of know my assignment, and I got these tools. I'm going to ask you to call or this tool. So there's a bit of a callback here, right? Where it's going to call our tool. Our tool's going to do things like maybe it's going to access a database, maybe it's going to call a cloud function, maybe it's going to do a specific calculation, that's our own IP. But it's going to bring back some information to our agent, and our agent is going to then, re kind of push that information back into the model along with all of the history that's happened. And then we're going to get the model again to reason out, hey, what should we do next in order to answer this question? And the model can say, hey, you know what? Given that last tool, I have the information, I can answer this. Or it can say, you know what? I think I would like the information down here first. So it's going to reason that out. Okay. So and once again, super high level, when we talk about reasoning applications, you know what, we'll go back to a little simpler diagram. The question's going to come in our agent, we're going to ask the model to reason out the next steps, given all the tools that are available. And it's going to reach back, it's going to do a callback to our system to act on that. We'll get some information and we'll rinse and repeat, right? We'll keep on adding extra information till hopefully that agent has, everything it needs in order to answer the user's question. Okay, I hope that made a little bit of sense. So now let's kind of see this in action, okay? Um, like I said, we're going to jump back and forth. So this is something that we've kind of developed that is a reasoning application that uses agents. Okay, it's a service we provide if you're interested in kind of kickstarting, dipping your toes into it, trying to experiment, like I said, through this evolution, getting a feel for its strengths and weaknesses. This is something that we can drop into your organization where, it's a chat-based application, as we're probably all familiar with now, web-based solution that runs in both Azure and AWS. And, as we can kind of see here, what we do is we support multiple models, so we can consume these large language models, where we have like things from Anthropic, right? Like we got Claude hosted in, various cloud providers, right? We got AWS, GCP. We can talk with OpenAI models, hosted in Azure. We got some Gemini with GCP and a host of other models, Llama. But the idea is that it is kind of interesting, and we'll show this as we go. We'll just touch on a couple of models because we're kind of constrained for time. But it is interesting to watch how these different models interact when we kind of work with this system. I'm going to skip over some of these run settings for now. But this is kind of the interesting part, right? And here's where, to get back to agents, these are like our data sources that we can chat over. These are, sometimes referred to as knowledge bases, right? Where, let's think of each of these sections as our agents within inside the larger system of a reasoning application. Okay, so we have an agent that is very good at being able to interact with, let's say, a classic, relational database. Okay, that's really what this represents. And every time it kind of sees this, I want to keep this in mind. Whenever this agent kind of looks at these databases, it's kind of like you or I, the first time ever we've ever seen this, and it's trying to figure things out. Okay, so this is an agent. We can support, chatting over, let's say, your own tabular data like CSV or Excel files. Organizations, companies were very good at building microservices, right? They themselves are, pretty much knowledge bases, right, that we can interact with. And then, depending on what you want to do, we can also kind of reach out the web to get some more real-time uh, information, right? And maybe kind of ask questions about that too. But this is kind of where, we can set up the configuration for your data and whatever environment you want to be in. So super high level view, but let's just kind of leave it at that. And like I said, as we demo this, this is kind of live, without a safety net. And the models that we're using are kind of pretty much deployed in a shared provisioning matter. So sometimes hopefully it doesn't happen, but every once in a while, we may get that noisy neighbor kind of syndrome where something's happening and a system gets overloaded. I hope it doesn't happen, but let's kind of see where this goes. And like I said, for this talk, what we're going to do is we're going to focus on the database engine. Like I said, limited time, and I think this will be a better way to see, what an agent is and the tools involved to relate to it. Okay, so from here, we've kind of set up some test databases. We got like AdventureWorks and Worldwide Importers, some classic Microsoft starter databases. But we're going to focus mainly around here, like in the intro. Um, I'm kind of interested in golf, not saying I'm good at it, but I do love the social aspect, getting outside. So we actually have a database here that deals with organizing golf rounds. So we're going to ask some questions about golfing. Okay. Yeah. Like Armando said, I live in Calgary, right? So Calgary weather is important. So we'll probably kind of be hovering mainly around these. But let's see this in action. And so we're going to select our data source. I do have this ability to kind of say, hey, we want detailed or minimal output. I'm going to start with minimal. And we're just going to ask how many rounds were canceled in 2020. Okay, now our agent's kind of kicking in, it's kind of doing its thing, it's bouncing back and forth, and it just came up with an answer. Okay, so this is like the first thing. So earlier in the year, at the beginning of the year, when we started uh, doing something like this as a POV for a client, you know, you kind of look at that and you're going, well, that's great. I got an answer, but I have no idea if it's correct, right? And so the first thing, if you're going to start to play around with these applications and get into the reasoning side of this, is we all, sometimes we want to actually see what's happening as, the model is thinking about and doing callbacks to us. So, we have different kind of levels we can run this thing at. So let's rerun this. Let's regenerate this at a detailed level. But the idea of observability is very important. Um, in this case, we're going to kind of echo some of these things out on the screen inside of our forward-facing application. But in addition to that, we also want some observability and traceability behind the scenes that we can go back and kind of view. And there's a lot of good products. If we kind of look at LangChain, which is a tool for making some of these systems, or a library of framework, they have an excellent tool called Langsmith. We may get in there, we may not, but just understand it actually does a great job of tracing everything that's happening behind the scenes. But anyway, let's go into a detailed version and let's regenerate this. Okay, came up with the same answer, which is a good thing. And the difference here is we got a little bit more information, right? And to build confidence and trust in these systems, we kind of have to go through and how do we tweak that to make sure we get to, better, more correct answers consistently. Um, we're going to see, you're going to see throughout here, we kind of have this calling. Okay. So we called this checker and then we called the SQL DB query. And this is really kind of the interaction that calls to a tool here. Okay. So as we go through this and we see this in action, you're going to see what it's calling. So in this case, it didn't do too much. It kind of checked our query for some mistakes and it output the query, which, if you're you're running this in production, you probably don't want to do this, but they're in development mode. or, gaining some comfort, depending on who your audience is. This is a great way to kind of to make sure you understand the answer and that it feels like it's correct, right? And then it calls the query and it's all good to go. So first introduction to the reasoning application in the agent. When I ask this question, my agent, which deals with the database, right, knows how to interact with the database, is gonna it's gonna say, hey, please execute this tool. We're gonna take the output, we're gonna pass it back in. There's two kind of calls back and forth between our system and the model in order to come up with this answer. Now, let's kind of go into something a little more in depth that we'll see more calls back and forth between the database or between our process and the model is, we're going to ask in the spirit of golf, we're going to stay with that. We're going to drop down to our worldwide importers and let's use Cloud 3.5 Sonnet on GCP. And this model is great, by the way. This model from Anthropic, fantastic. Um, and the interesting thing about this, so I'll let this run. The interesting thing about this is it's very verbose and it really echoes out kind of what it does and kind of spells things out, which is pretty wild. Now, remember what I said is think of this as if you were tasked to answer this question and you have never seen this database before, that's kind of what this is doing as we kind of work through here. Okay. And it's actually the reasoning application and the agent is figuring out the structure of the database, kind of going through, and let's just kind of walk through this. Okay. So it's going to investigate our product catalog. So kind of knows some information about this data source, and it's going to look at say, hey, what tables are available in our database. So it's going to call back to, let's say, a tool that does one thing and does it well, list the tables of a database, right? And it's going to give us all of the tables that are available and the names of these. And then it's going to reason out what we should do next. Okay, so it's going to look at, it goes, well, based off of all these tables, it looks like stock items is an interesting name. Maybe that, because we're asking, do we sell any golf related equipment? It goes, oh, it can reason that out. And it goes, I think that's the table we want to look at. So then it's going to call out to another tool that says, okay, give me the schema of that table. So yeah, so you can see if we're going to pass in stock items, and right, and it's going to call back to our system. And what we're going to do is what happens is it ends up dumping out the schema of the table and providing some, sample rows, right? And all of this information is going to get passed back in to make sure that we're still okay and we're on track. And now it's going to query for golf related equipment. And for whatever reason, it decided stock item name. That's logical. Marketing comments. That's interesting. And, and then this is kind of the power is as we start to kind of play with this and we start to be able to interact with, our own information in a different manner, we can ask these kind of questions and we can lean on the reasoning power of these models in order to give us different insights and kind of look at things differently, right? So, because I told it to expand the terms, right? It knows it's dealing with golf. And you can see, okay, it introduced like golf, tee, club, driver, wedge, iron, ball. Those all look pretty good. Glove, right? Um, but that's just something different for us when we build software, right?
Michael,
If the question pops up again, just feel free to like fire it off in the chat and we can address that, at the end. Um, but yeah, as we kind of go through, right, we're leveraging the reasoning power of this model to kind of help us through. And once again, it's going to kind of do a check on this. It's going to look good. And then it goes through its analysis where it says, hey, I think I've done everything I need to do, right? And it says, no, we don't, and then it logically kind of comes to a conclusion and tells us why, right? Where we did this search term, the only item that matched was a white chocolate snowballs. But it's got the smarts and the ability to say this is not related to golf, and then it kind of gives a summary of what it did, right? But this is kind of the interesting thing for us to experiment, like I say, and ideate over to provide value in different areas that, we may not have been able to before. Okay, so I hope this kind of idea gives a little bit more insight into, you know, what a reasoning application is and what an agent is, and how there's this interaction between, our agents over here in the sprocket and the model, and we're leveraging the fact that it's trained on billions of parameters and it has some smarts to it. Okay, so let's move on here. Okay, the next step we're going to talk about um, is evolving, right, into something called supervising agents. These can be called hierarchical agents or, a controller of sorts. And, once we have agents and we build like a little arsenal of them, right, where they're good at, like, say, interacting with a database, APIs, web, whatever, we can then kind of go up a level and we can have, like, let's say, a supervising agent. And the supervisor at the top is usually structured in such a manner, like, let's say it's a business process or a workflow. And based off of the question, it's going to delegate down to the agents, right, that do one thing, do well, that, it could be one or many. And they're going to kind of go through what we just saw, where they interact with tools, bring back some information. Then the supervisor is going to do some stuff to kind of say, hey, given, let's say it's a chat-based application, did we answer that question or not? Okay, now this is a pretty powerful method. And like I say, once we get a handle on, a basic agent and interacting with tools, now we can go up a little bit higher. Okay. So in terms of, an example of this, let's kind of clear this. Um, let's let's go Alberta Golf and Calgary weather. We'll select two data sources. And when we select two data sources within the Data Explorer, we're kind of kicking into this. We have a supervising agent that can kind of understand the data sources and determine what it should be doing. And we'll go to the latest and greatest OpenAI model for O-Mini. And we're going to ask, is there a correlation between the number of golf rounds played every month of 2021 and the average temperatures for those months? Now, this is a relatively not a complex question, but great for showing this supervising agent in action. Okay, like the answer is hopefully yes. But let's kind of let this run. It's doing its thinking. So you can see it determine a plan. Now all kinds of stuff is happening here. We're just going to kind of let it do its thing. The interesting thing is this finishes. Um, as we kind of deal with these models, they're very good at generating markdown, right? So behind the scenes, as we kind of evolve this, it was like, okay, let's change our prompts and let's add a little bit of a presentation concern into our prompts and say, hey, can you please return, things in Markdown for, so that it's easily displayed and has a better presentation. So, um, and then what we did is we kind of changed our front end to be able to handle Markdown and render Markdown, right? A pretty wild concept, right? And so now we're kind of not only are into, generative, like, information, we're now kind of into a generative UI. So for example, like this is a code block markdown that it generated. This is a table, right? Now on the front end, we're not actually doing anything. We're just rendering markdown, right? And we're relying on the model to do that for us. So a little bit of a tangent, but kind of interesting, I think. But let's kind of get back to this agent and the supervising agents. Is you're going to see first off when we ask this question, based off of, these information. So this database has information on golfing. This database has weather information. Not very descriptive, but enough. It kind of came up with a plan, okay? And All of this is kind of under that guise of a supervising agent. So, we can say, and then it's going to go through and it's going to delegate down to those agents that we were kind of looking at before, where it's going to ask a question for the golf rounds. It's going to figure out some stuff. It's going to do the output, and then it's going to ask something for temperature. And then given all that information, it's going to do a bit of analysis, right? And come up with an observation, and it says there's a noticeable drop in round in colder months. Makes sense, right? Uh, so yeah, there's a positive correlation based on the data. There seems to be a correlation. So, but this is the idea of a supervising agent where we can delegate down to other agents in order to come up with, a solution. So let's we're going to get into a little bit of a gory diagram. Not horribly gory, but this is a classic state diagram, and this is how we implemented this supervisor as a state diagram. And I'm going to say we got these things called actors. Okay, like in order for us, this is kind of our, in order to solve, hey, we have multiple data sources and answer a question, what we've done is we've introduced, I'm going to call these actors, right? So we got a planner, right, which we kind of saw here, whose sole responsibility is to come up with a plan. Okay, we got an executor that executes our agents. And then once they're done, we introduce something called an analyst that's going to say, hey, given all this information, can you answer this question or not? And if yes, we're going to end and we're going to return the answer. If not, we're going to go into a replanning mode, right? Say, hey, here's what we've done so far. We got this information. What's our next plan that we should do in order to answer this question? And then we get into a bit of a loop. As we built this, the interesting thing, and I can't stress this enough, this single responsibility principle, is we kind of thought we could have, after the executor goes, we could have an analyst and a replanning in one, let's say, prompt, but it was very inconsistent. And so we separated that out into an analyst and a replanner, way more efficient and way more consistent. So just to understand what's happening, as we go through this, we're actually doing a call. We have a separate prompt that says, given these data sources and this question, come up with a plan. That's really what this is. Okay, and we're going to do a call to a model, a large language model. It's going to come up. It's going to give us some questions to ask. We're then going to pass those down to our agents. And then, like I said, our analyst is going to go through and say, hey, given this information, we have another prompt designed just for an analyst that's going to say, given this information, what result was this answered or not, right? And then if not, we're going to replan, right? So our prompt is a little different for replanning. But in these kind of reasoning applications, the idea of kind of what I wanted to get across here is, as we build software around this, we start to realize we can use, these models for various aspects within the entire workflow or process. Now, this is kind of important because I think that's where some very interesting applications are going to arise. Okay, we better get moving. I might be a little bit behind in time. Okay, so this is kind of, how I said, I just kind of wanted to touch on this. We got human in the loop, okay? Um, as we kind of work our way and we evolve, right? We're in an evolution of trying to figure out how to actually build systems around this, get comfortable, right? One of the things we can do is we can introduce a human in the loop. So we have our agent. It can do one thing. It's good at solving a particular problem, and it's got a bunch of tools on here. But in order for us to gain trust, or sometimes, if you're like you need approval before we do something, like let's say we want to change state in a system, we may need approval. Maybe let's introduce, after it kind of does a bunch of things, maybe let's introduce the human in this loop in order to like provide more information that the tools weren't able to, or to get approval to execute something. Very important. And, you know, maybe warranted depending on what kind of process or workflow you're building. So the interesting thing here is it does add a little bit more complexity, right? Because the application or the system itself, in order to answer the question, it may do a bunch of work and then it may go, hey, I need approval or I need some extra information. The model may reason that out and it says, hey, I'm going to call my human tool to get an answer. Now, that means we have to pause our current state so that we can get an answer, and then we want to resume. We don't want to start from scratch again. We want to kind of keep that current thought process. So that's a little tricky, right? Adds a little complexity, but still worthwhile. Okay. Because that response from a human could be, you know, could be a minute, could be a couple days, but that we still want to be able to, maintain that state and resume based off, pick up where it left off. So we're gonna kind of see this in action with this data explorer. We're gonna clear this again. Um, let's see, we'll go with Alberta Golf, go to 4.0. And there's a setting in here just to kind of experiment, right? Where we can say, okay, let's introduce a human in this loop, right? And when we do this, we're going to change our prompt. We're going to add a little bit of extra information to say, hey, if there's anything you don't know, right, that you're a little uncertain about, a little bit of doubt, user asks for approval, make sure you reach out back to the human to get some input. Okay, and this is kind of interesting. Okay, so immediately it got tripped up. So we have a tool in here that we can actually, inspect a database and then we can actually, export some information as Excel or CSV, but those are the two options. So because we instilled a little bit of doubt into the system, it's like, okay, I got this tool available. What do you want? Do you want this in Excel or do you want this in CSV file, right? So it's immediately asked us. So we'll be nice and polite. We'll say CSV, please. Um, now, a, a bunch of work wasn't done before, but, it kind of picked up where it left off. And once again, inspected our database, figured out what it should do, created some SQL, exported some results, stored it in the cloud, generated some markdown for us so we can download it, all this kind of good stuff, right? So here's a very simple example of introducing human in the loop. And once we kind of check this off, in Data Explorer, we can start to play with that and get a feel for how this would all work together. Another one, I kind of said, okay, well, let's go with an approval process. Okay, so we still want human in the loop. I'll go with 3.5 Sonnet again. Is how many rounds were full in 2020. And I'm basically saying, okay, just to kind of show the idea of, hey, let's let it do some stuff and then kind of get our approval before executing it, right? And we can review it. But these are the kinds of things to think about as you kind of write these systems is, if we want to introduce a human, where would we do this? And this one's kind of dynamic in nature. Okay, Claude's kind of ripping through here. It's going to do its stuff, comes up with this query. And like I said, how we had this calling bit, right? So you see now the human is actually a tool in the loop. Kind of a weird thought, but we're kind of like a tool in this. And when I kind of look at this, knowing this system, like I know this column doesn't exist. Now, I could give it approval and it'll probably figure this out, but instead, I'm going to say instead of start date, because this column is actually wrong. Um, right? So this is actually a good thing for us to get approval on. And it did a correction. It's going to do some more work, but it's picked this. The agent is pausing in between, maintaining state, so that when we kind of come back to it, we can continue. Now I look at this. This kind of looks good. It's asking us again, hey, do you approve of this updated query? And I'll say, shall I proceed in executing it? Let's just say yes. And it's going to go along its merry way. Kind of does a query and it says, gives us information that we had 288 full rounds in 2020 and gives us a bit of confidence level. That's something that, we've added in our prompt to say, hey, when you're kind of done, this is a little bit of an experiment. But generally, this is kind of interesting. The whole point of this is the fact that we had a bit of a conversation and we introduced a human in the loop. Super high level. Here's our state diagram of what we just saw. Is when the question comes in. This is our agent calling out to our tools and getting some information. And then, because we kind of left this open-ended, we're saying, hey, if you've ever kind of have any sort of doubt, you need some more information. Um, the question asks for approval. At some point in time, you're going to ask for human input, and then we're going to interrupt. And this is kind of where we pause it so that we can pick up where we left off. And then once that's kind of done, if it has all the information it needs, it's going to end. Okay. So quickly, let's just kind of see what that would look like. This is like more of we're kind of leaving it up to the LLM to decide when the human should provide input, right? A little more dynamic in nature. Let's say we had a process that we really, in a certain area, we really need the human approval, right? So I'm going to go back to this same kind of question, the correlation between golf rounds played and the average temperature for those months. We'll go back to Mini. We'll select multiple data sources. Now, the reason I'm going to do this, right, and this drops us back into our supervising agent, is the way we've structured this is within a supervising agent. I don't know if you remember, but the idea of the supervising agent, it does a plan. We're going to want approval first. So this is where within our process, we've defined a certain state that the system gets into. And when it does, we need approval before we go. Okay, so we're not leaving it up to the LLM. We're actually programming this. And as we work through this and we build systems around these models, there's going to be areas within this workflow that we really need human approval. And that's really what this is trying to demonstrate is when we do a plan, in order for you to continue, we got to approve this, right? So it's asking, do you want to continue with the current plan? And I'll say, oops, let's do this for 2023. And what it's going to do is then it's going to replan, and it basically came up with the same plan, just substituted 2023. And then we'll just go, yep, all good. And it's going to go through the same things that we saw before, where now it's going to delegate down to our agents that know how to interact with databases, call all the tools that do things, gather some information, and come up with a conclusion, that it suggests a positive correlation. Uh, the interesting thing here, like I said, the thing I want to highlight is sometimes when we build these systems around these models, right, we kind of go through, there's going to be certain processes or workflows that we definitely need a human input. And like I said, we've specifically said, hey, in our case, if this is checked off and we have multiple data sources selected, which means we're going down our supervising agent, we introduce, a node here called Ask Human, right? And we pause until we get feedback from the human. Now that feedback can be, in our case, if we look at this, our first input said, hey, no, let's do this for 2023. Now that's not an approval, that's actual feedback, right? And this one said, yep, go ahead and do it. So we actually had to introduce this thing called the well, what we called, an actor, a human interpreter, where based off of what it says, we have a prompt and we say, okay, given what the human answered, was there feedback in there or did they approve it? Right? And then based off of the input, we may replan kind of what we did here. We did a replan and then we got approval to do it. And then when we said, yep, the model is smart enough to interpret that response and then go down the executor path. And this is kind of the normal flow again. So these are all kind of high level, you know, thoughts and processes, but very important when we build these reasoning applications with agents, introducing a human in the loop during this evolution process as we get comfortable using this and working this into our software, going to be an important part. Okay, we are down to like 10 minutes, which is actually pretty good for us because I thought for sure I'd be, going over time. A couple things we didn't quite get into that I want to talk about being noteworthy is, as we dip our toes in this and we start to evolve, building software around this, to gain confidence, you want to start narrow or start small. Don't try to boil the oceans, right? Get familiar, like I said, where it shines, where it doesn't shine. Um, and then grow out, right? Like you don't want to tackle too big of a problem to start. If you haven't been working in this area, yeah, start narrow. The other thing I kind of want to talk about is evaluation. So just like any good software, right, as we build this, we want to be able to provide a harness, right, where maybe we want to exercise our system, try it against different models, and determine how good these things are and gain some confidence. We may have to tweak our prompts in order to like drive it down certain paths that it can keep on giving us, more consistent, correct answers. And this evaluation part's very important. So I'm just going to quickly jump into, I kind of mentioned this earlier, like LangChain has a great tool called Langsmith. In addition to observability, we can actually start to build, uh, you know, basically it's like an integration test. We can start experimenting with things. And the interesting part here, and what we've done is we have a set of answers that we, question and answer that we know have I don't know, a correct response. And you can see here what we've done is we're kind of validating against various models, running different experiments against these things. And these are just all the models that I kind of showed you in this drop down. And, over time, we can see, okay, we can do this thing called a correctness of thought, right? Where, you know, a score of 1 is you got everything correct, right? And you'll see, and it's interesting to see over time. So 4.0 is always correct, and then all of a sudden, 4.0 kind of missed one, right? And that's a reality is even if we deploy these models, right? They are in the cloud provider. There's little tweaks that happen that could impact our systems, and we always want to gain comfort that it's operating correctly or to its best ability. And so when I say this correctness of thought, and this is a weird kind of mind shift. What we're going to do is we're going to exercise our system. We're going to run our agents, and we'll go down to the one that is incorrect. Okay. And we'll go to this evaluator. And so we exercise our system, we get an answer, and then we're going to ask another model to actually grade us, right? So this is another call to an LLM that says, hey, grade the answer that was generated from this other LLM in order to tell us if we got the response correct. I don't want to go into this too much, but the idea is that, like I said, we have questions. How many golf rounds were open? The correct answer is 56. And for whatever reason, the student answer or our system, our agent gave us 425. So this model concluded that that was incorrect, right? And then we would kind of go back and evaluate it to kind of see why it gave us a wrong answer or what can we do to actually nudge it in the right direction. So when we talk about building these systems, this evaluation is pretty important to kind of bake in from the beginning. Um, I didn't quite get into this too much either. I know I mentioned the words prompt, and we are a little, short on time. Usually when I give this talk, it might be like an hour and a half, and we'll kind of get into we'll look at the prompts. We'll go a little bit more detail into them. But early in the year when we started to build these kinds of systems, it was like, okay, we had the prompts baked into our code. And, as we evolved, we started to comment things out, change up, and, it soon became apparent that we don't want that in our code, and we want these prompts, every little callback out to the model that involves a prompt, we want those managed somewhere else, right? Independent of the code, and we want that in its own life cycle. And, we stumbled across this tool called Human Loop, where when we run something, I'll just kind of give a brief little overview of this. Um, essentially, this is like a little dashboard. I mean, it does a bunch of other things as well, but the interesting thing that we did this is where we can actually change our prompts. We can see what differences they were. We can run experiments on which prompts were more effective, which prompts were less effective. And, we can choose to deploy certain prompts, right? And then, see how that impacts our system. But the idea of doing this outside of your code, kind of important and a different mindset, right? Prompt engineering is a real thing and it impacts how these systems behave. So moving that prompt management outside of your code, kind of important. Um, Especially when we get into production. You know what? I'll skip over performance. I want to leave a little bit of time for questions. Um, Multiple model designs. Sometimes, in order as you build these, you may leverage different models to be more cost effective. You may not need to use the latest and greatest, like, 3.5 Sonnet, maybe like dropping down to a simpler model for certain tasks within your system. You may introduce multiple models within here for efficiencies. Okay, look at that. 6 minutes left.
Amazing, right on time, Michael. I have one question for you already, really interesting stuff. It says, are there any challenges with the interaction between the model and the agents?
Yeah. So you know what? Um, Everything's getting better, and you're going to hear things like function and tool calling. And this is kind of where we kind of see the shift. Like early on, it's a huge challenge, the structured response, because like I said, when we interact with a model, because we're dealing in code, we kind of expect a response in a certain format, right? And, in the early days, I still do it sometimes too in my prompts, is I'll say, hey, return your responses, JSON, right? Um, but it can get very tricky. But you can see that over time, especially the open AI models, and I'm seeing it now in most models, they support this thing called function or tool calling, where there's a bit of a protocol so that, these the open AIs, the Anthropics, they know that, integrating a model within a system and allowing this function callback is very important, right? So it's gotten better and better and more consistent. Some models still don't support it, and there is a fallback technique to kind of do this, and you know, it's more of a React prompt or a chain of thought prompt, and we do it in some places because some models they're not as good or not as mature in the space of calling back to our system. And it's quite a bit different, but it does work where we actually get it to spell out its action, its thought process and its action. But then we have to parse that out, which is like pretty horrible work. And that's when you want to lean on some of these frameworks like LangChain. So yeah, there are some challenges, but if I compare like let's say the end of last year, the beginning of this year till now, wow, in a short period of time, it's like it's way better.
Thank you for the answer, Michael. And we don't have any more questions. So do you have any closing statements or thoughts for us?
Not really. Outside of, like I said, given the state of the union, there's no bad idea in dealing with generative AI and trying to see how it can help your organization. Um, and yeah, I think the most important part is, you know, to iterate over it, to ideate over it, and see how it can help, can help you solve problems in different manners.
What a great session, Michael. I want to thank you all for joining us, and especially you, Michael, for sharing this presentation with us. And as he said, audience, make sure to reach out directly to him to discuss how and where Gen AI and the Data Explorer can work for you. And coming up next week, Bill Corey, our Vice President of Consulting, and his webinar, The Power of Low Code, No Code, Frameworks for Business Transformation. Until next time, everyone, have a great rest of your day. And again, Michael, thank you for being here.
Thanks, everyone.